Imagine if dragons were real. Imagine a world where dragons soar through the skies, their massive wings casting shadows over the earth below. But is such a creature even possible? Let's dive into the science and explore the implications of dragons existing in our world. First, let's consider the biology of dragons. For a creature of that size to fly, it would need to overcome significant challenges. According to the journal PLOS-1, the largest flying creature known to have existed is the pterosaur Quetzalcoatl northropi, with an estimated wingspan of up to 10 meters. These creatures push the limits of what is biologically feasible for flight. To support flight, a dragon would need a lightweight skeleton, likely with hollow bones, like birds and pterosaurs. This adaptation reduces body weight without compromising structural strength. Additionally, powerful flight muscles and an efficient respiratory system would be essential. But dragons are often depicted as much larger than any known flying creature. The physics of flight impose strict limitations on size. According to the square cube law, as an object's size increases, its volume and mass grow faster than its surface area, making flight increasingly difficult. Therefore, a dragon's size would need to be within realistic limits to be capable of flight. Now, what about fire breathing? Is there a biological mechanism that could allow an animal to produce and expel fire? Interestingly, some animals produce combustible chemicals. According to the journal Science, the bombardier beetle, for instance, can eject a hot chemical spray as a defense mechanism. The beetle stores two chemicals, hydroquinone and hydrogen peroxide, in separate chambers, which mix and react violently when threatened. Applying this concept to dragons, they could theoretically have specialized glands to store and mix combustible chemicals, igniting upon expulsion. The challenge lies in controlling the combustion and preventing self-inflicted harm. Protective adaptations, such as heat-resistant tissues, would be necessary. From an evolutionary standpoint, the development of such traits would require selective pressures favoring these adaptations. Predation, competition, and environmental factors could drive the evolution of flight and defensive mechanisms like fire breathing. Now, let's delve deeper into the physics of dragon flight. To achieve lift, a dragon's wings must generate enough upward force to counteract its weight. According to Bernoulli's principle, the lift generated is proportional to the surface area of the wings and the square of the airspeed over the wings. For a large dragon, achieving sufficient lift would require either enormous wings or extremely fast flight speeds. Enormous wings pose structural challenges, as they must be strong yet lightweight. Alternatively, high flight speeds increase energy demands and reduce maneuverability. Moreover, the muscle power required for flight scales with muscle cross-sectional area, which increases with the square of body length, while body mass increases with the cube of body length. This discrepancy means larger animals have relatively less muscle power to support flight. To overcome this, dragons might have evolved advanced muscular and skeletal adaptations. Perhaps their muscles have a higher power output per unit mass than typical vertebrate muscles. Or they might utilize a unique energy storage mechanism, such as elastic energy storage in tendons, similar to how kangaroos enhance jumping efficiency. Regarding fire breathing, the chemical reactions involved would need to produce high-temperature flames without harming the dragon. One hypothesis is the use of methane production, similar to how ruminant animals, like cows, produce methane during digestion. Dragons could harbor symbiotic, methanogenic bacteria in a specialized organ, producing methane gas. To ignite the methane, dragons might generate an electric spark, akin to electric eels producing electrical discharges. Alternatively, they could use pyrophoric substances, such as diphosphane, which spontaneously ignite upon contact with air. Producing and handling such reactive chemicals would require complex biological systems to safely store and control them. Ecologically, the existence of dragons would have profound impacts. As apex predators, dragons would sit at the top of the food chain, potentially disrupting existing ecosystems. They would require vast amounts of food to sustain their energy needs, especially if they are endothermic, maintaining a constant body temperature. Their presence could lead to the decline of large herbivore populations due to predation. This, in turn, would affect vegetation patterns and the overall health of ecosystems. The balance of nature would shift significantly to accommodate such formidable creatures. From an environmental perspective, dragons emitting methane or other combustible gases could contribute to greenhouse gas levels, affecting climate change. Their predation patterns could lead to trophic cascades, where changes at the top of the food chain ripple down to affect multiple levels of the ecosystem. Now let's consider human-dragon interactions. Throughout history, humans have competed with apex predators. The arrival of dragons would pose significant challenges to human survival and development. In areas where large predators exist, humans have developed various strategies for coexistence, including hunting, habitat modification, and defensive structures. With dragons, these strategies would need to be amplified. The construction of fortified settlements might become commonplace. Architectural designs would prioritize protection from aerial attacks. Materials resistant to fire and strong enough to withstand impacts would be essential. Economically, dragons could influence trade and industry. Dragon materials, such as scales, bones, or even dragon-produced chemicals, might become valuable commodities. This could lead to industries centered around dragon harvesting, raising ethical and conservation concerns. Culturally, dragons would likely play a significant role in mythology, religion, and art. They might be revered as deities or feared as demons. Stories and legends would revolve around them, influencing societal values and traditions. In terms of domestication, could humans tame dragons? The domestication of animals depends on factors like temperament, social structure, and reproductive cycles. Dragons, being intelligent and powerful, might resist domestication. However, if they possess social behaviors similar to pack animals, there could be potential for forming symbiotic relationships. The presence of dragons could alter the course of history, affecting trade routes, wars, and the spread of cultures. On the flip side, if humans could harness dragons, perhaps using them for transportation or warfare, the strategic advantages would be immense. Airborne travel and combat could revolutionize societies. From a scientific perspective, studying dragons would offer insights into biology, physics, and chemistry. Understanding their flight mechanics could inspire advancements in aeronautics. Investigating their fire-breathing abilities might lead to breakthroughs in combustion technology or bioengineering. Technologically, the necessity to monitor dragon movements might advance surveillance technologies, including radar systems, satellites, and drones. This could have spillover effects into other areas of science and industry. Ethically, the existence of dragons would raise questions about conservation and coexistence. Efforts to protect endangered species might extend to dragons, especially if their numbers dwindle due to human activities. In modern times, environmental concerns might focus on the impact of dragons on climate and ecosystems. Their large size and predatory nature could influence carbon cycles and biodiversity. Furthermore, the fear and fascination with dragons could influence literature, media, and entertainment. They might become central themes in storytelling, reflecting human experiences and emotions. In terms of public health, dragons could be carriers of zoonotic diseases, transmitting pathogens between wildlife and human populations. This would necessitate advancements in medicine and epidemiology to manage and prevent outbreaks. Moreover, the psychological impact on humans could be significant. The constant threat of dragon attacks might lead to heightened stress levels in populations, influencing mental health services and societal behaviors. In education, fields like dragonology could emerge, dedicated to studying dragons' biology, behavior, and interactions with the environment. Universities might offer specialized programs, leading to new professions and research areas. International relations could be affected as well. Nations with dragon populations might develop unique policies, either protecting dragons as national symbols or engaging in eradication efforts. This could lead to conflicts or alliances based on dragon-related interests. Finally, considering the long-term evolutionary trajectory, dragons could continue to evolve alongside humans. This co-evolution could lead to changes in both species, potentially resulting in dragons becoming more elusive or developing new adaptations in response to human activities. In exploring the question, what if dragons were real? We uncover a tapestry of scientific, ecological, and societal threads that illustrate the interconnectedness of life on Earth. While dragons remain mythical, this thought experiment highlights the incredible diversity and limitations of life and the profound effects such a creature would have on humanity and the planet. It challenges us to think critically about biological limitations, ecological balances, and the implications of introducing a new apex predator into our world. While we may not have dragons soaring above us, the exploration of this possibility helps us appreciate the wonders of the natural world and the interplay between science and imagination. Thank you for joining us on this imaginative journey grounded in science. Until next time, keep wondering, what if? If you found this exploration thought-provoking, please hit the like button and subscribe to our channel. We release new episodes every Friday evening at 5 p.m. Eastern Standard Time. So stay tuned for more intriguing Imagine If scenarios. Thank you for watching and keep imagining the possibilities. Please let us know if you have a question you would like us to try and answer or something you would like us to imagine.